Hey guys, we're working out page 1 of the Intermediate Algebra Final Review. Okay, these problems will be problems where you have to show all of your work on the final. So let's start. First off, number 1 says to factor out the GCF. So let's find the greatest common factor between 50 and 98. Both of those numbers are even, so we can try 2 and see if it works. The numbers 50 and 98 do not share any number that's bigger than 2, so 2 is going to be our GCF. Then we look at x's. There are x's in every term, so that means we're going to have at least an x out here. And our smallest exponent on an x is a 1, so that means it's going to be just 2x out there. So we divide both terms by 2x. We end up with 25x squared, because we divide 50 by 2, and we subtract exponents on x's. So 3 minus 1 is 2. And for our second term, negative 98 divided by 2 is negative 49. And x divided by x cancels out. We're normally done at this point, except the inside part of the parentheses is a difference of squares. We have two terms, both of them are perfect squares, and there's subtraction in between. So we are going to have to find the square root of both of those terms. Okay, I'm going to bring down that 2x that we already had, and then our one set of parentheses factors out into two sets of parentheses, one with a plus, one with a minus, and the square roots of each of those pieces go in our parentheses. Square root of 25x squared is 5x. That goes in the first position of both parentheses, and the square root of 49 is 7, so that goes into the second position. Okay, there's no more greatest common factors, there's no more x squareds, so we are done. This is as factored as this problem gets. Number 2. These are some pretty big numbers, so we definitely should be looking for a greatest common factor. The number 100 goes into all three terms. 100. Then again, there are x's in every single term, so we're going to take out an x to the first power again. And let's divide all three terms. 100x cubed divided by 100x is just 1x squared, or x squared. 300x squared divided by 100x is going to be a positive 3x. And then negative 1000x divided by 100x is negative 10. The inside is a trinomial. We've got three terms. The first one is an x squared, and there's an invisible 1 in front of that x squared. So that means that we can use the shortcut method to factor. Okay, we are looking for two numbers that multiply to get negative 10 and add to get 3. Okay, so we can go ahead and put x and x in both of those pieces. We know there's one positive and one negative because 10 is negative, and we need the two numbers to add up to get 3. Our possible numbers are 1 and 10, 2 and 5. Since our middle number, 3, is positive, our big number is going to be positive, and we said the signs had to be different, so that means small number is negative. Our numbers are negative 2 and positive 5. There we go. There's a minus 2 and a positive 5. And then, of course, we cannot forget our GCF, which is out here, so make sure that you bring that down as well. On this problem, we are factoring to solve and find all the zeros of a polynomial. So the goal on this one, first off, is to set the equation equal to 0 and factor. This equation already equals 0, so we're good over there. The left side is a trinomial. There's an x squared, but the number in front is a 2. So this is not going to be a shortcut method. We need to do the whole split the middle. Okay, we're looking for two numbers that multiply to get negative 40 because our first number times our last number is negative 40. 2 times negative 20. Our possible numbers in the chart are 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, or 5 and 8. We know we're going to have different signs because 40 is negative, and based on the fact that our 3 there in the middle is negative, our big number is the negative one. All right, from here we need to pick our two numbers. They are supposed to add up to get -3. We already know that they multiply to get the -40, so we're good there. Looks like 5 and -8 add up to get -3. So we're going to rewrite our 2x squared minus 3x minus 20, but replace the -3x with 5x minus 8x. Bring down that -20, and technically that little equals 0 needs to follow along. All right, we're going to factor by grouping here on the left. Nothing goes into 2 and 5, so we're just taking out an x from the first two terms. Dividing that x out as a GCF leads 2x plus 5. And in our second set, our first term is negative, so we know the GCF has to be negative. And then we can divide out a greatest common factor of 4. We are not taking out a greatest common factor of x on those last two terms because there's no x in the very last term with the 20. Okay, let's divide out that GCF. So -8x divided by -4 is 2x, and -20 divided by -4 is +5. That's awesome because our two sets of parentheses match each other, and that is the goal. Our answer for the factoring looks like x minus 4, which were the two numbers that were on the outside, and then 2x plus 5 from the matching set of parentheses. So currently we have this factored out, but we have not found the zeros. Finding the zeros means that we need to set each factor equal to 0 and solve each factor separately. So I'm going to have x minus 4 equals 0, and 2x plus 5 equals 0. And now we do the one or two step equations to solve. So we add 4 to both sides, getting x equals 4. And on the other one, subtract 5, 2x equals -5, and divide both sides by 2. X equals -5 over 2, or -2.5, however you want to write it. So the goal is to get those two x values there at the end. Number 4, we are using synthetic division. The first thing we need to do is set our second polynomial equal to 0 and solve for x. This should be a very quick little equation to solve, and we always get just whatever the opposite number is. That number is going to go over here in a little box. Okay, and then we ignore that work for the rest of the time. Now we're going to take whatever numbers and terms are over here in the first polynomial and put them in standard form. So that's biggest to smallest exponent. But we really only care about the numbers that are in front, so the coefficients. So that would be the 7, the -71, 68, and 39. Okay. We always draw an arrow down from that very first number, and then we put a box underneath at the very end. That's going to hold our remainder. Okay, let's take the 7 down, and then we are going to multiply the 7 down there at the bottom times our red number, which is the 9. That answer is going to go in the very next position that's available, which is going to be up here. Okay, so as you multiply that bottom number times the 9, the answer goes diagonally up. Okay, 7 times 9 is 63. And then we add straight down and end up with -8. Okay, -8 times 9 is our next step. Multiplying the -8 from down at the bottom times the 9 in red, getting -72. Add straight down and we get -4. Multiply the -4 down there at the bottom times the 9, and we get -36. And then add straight down, and we get a remainder of 3. Okay, from here, we have to write our answer. The remainder is a number, it is a 3, and it is going to go on top of the x minus 9, which is what we were dividing with to start. Okay, then working from the right-hand side, -4 is our constant. -8 gets an x, so -8x. and 7 gets the x squared. And that is our final answer. On number 5, we are dividing a rational expression. This is something we did in a very recent chapter. This is the type of problem where we are going to switch the second fraction by flipping and change this to multiplication. The first fraction stays as x squared minus 2x minus 35 over 3x squared minus 12x. But the second fraction flips over and we switch divide to multiply. So that ends up getting 3x over x plus 5. We're going to now factor top and bottom of both fractions if possible. Top of the first fraction is a shortcut. We have x and x. Since the 35 is negative, we have one positive and one negative. And the two numbers that multiply to get negative 35 and add to get 2 are positive 5 and negative 7. And notice that the bigger number, the 7, is negative because your middle number, negative 2, is negative. Denominator, greatest common factor. Always look for a greatest common factor first. 3x is our GCF, so that's going to come out, and let's divide. 3x squared divided by 3x is x, and negative 12x divided by 3 is negative 4. In our second fraction, 3x does not factor at all, so we just have a 3x. And the denominator, x plus 5, again does not factor. There's no GCF, and then there's no x squared, so it's not like we can do a shortcut method. Okay, so I just put the x plus 5 in parentheses so that can help us cancel. Okay. Now, from any top and any bottom, we can cancel just one factor that matches another factor, x plus 5 and x plus 5. And 3x and 3x can cancel. The x minus 7 and the x minus 4 do not cancel, and they stay exactly where they were, x minus 7 on top and x minus 4 on the bottom. Okay. On number 6, we are graphing a polynomial, so we need to make sure that we are plugging this into our y equals in our calculator. So turn on your calculator, hit y equals, and clear out anything that is there. Type in x to the 4th plus 5x cubed plus 6x squared plus x minus 3. After you get the equation typed into y equals, you're going to go to the table. So that's second and then graph to get to table. And then I'm going to draw the table that I get over here, x and y. I'm going to write down all of the points that will actually fit on our graph. So negative 3, negative 6, negative 2, negative 5, negative 1, negative 2, 0, negative 3, and then 110 doesn't exactly fit on our graph, but it gives us at least a direction that we're going. Okay. I recommend at this point also hitting graph, just graph, not second graph, so that you can see what your picture looks like, so that you can make sure that the end behavior is correct. So the left and the right side are going up and down how they're supposed to. Okay, let's zoom in on this graph. We need the point negative 3, negative 6. Negative 3, 1, 2, 3, 4, 5, 6. Down here. Negative 2, negative 5. Negative 1, negative 2. 0, negative 3. And then 110 is going to be way up here somewhere. Okay. Based on the picture on the graph, we are starting up very high, and we're coming down here to that negative 3, negative 6, turning around again, and then when we get to 0, negative 3, we're turning around, and we're going all the way up to that point that is off of our graph. Okay, as long as I can see the points that you have graphed and I can see that the end behavior looks good, you're going to get your points on this problem.